For Unit 9, we are going to be talking about solving systems of linear equations. So a system of linear equations consists of two or more linear equations, and we are going to be working specifically with linear equations with two variables. All right, so here's just some examples of what they look like, okay? There's an x and a y in every single equation. So up to this point this year, we've only solved equations that had an x in them. But now we're going to learn how to solve equations if they have an x and a y. Okay? Your solution to a system of equations is going to be an ordered pair. All right? So remember, an ordered pair is x comma y. So when you solve them and get x and get y, you just write them as an ordered pair. Okay? Now, there are several ways to solve these equations, and today we're going to talk about doing those with graphing. Okay, so we are going to solve systems equations by graphing. All right, if you have two lines of a graph that intersect at one point, like this one all the way on the left, we are going to have at least one solution. Okay. If you graph two lines and they are parallel and they never intersect, it's going to be no solution. And if you graph two lines and they fall on top of each other, so this looks like one line, but what it really is just two lines. That was not good. Two lines that are exactly on top of each other, okay? Then your solution is going to be all real numbers. All right, so that's the three different scenarios that you might see when you're solving systems of equations. All right, but before we get into graphing, we are going to practice determining if you're given a solution, if that is a solution to a system of equations. All right, and the way we do that is we just plug it in. So this is x and this is y. So first, I'm going to plug it into my top equation. All right, so 2x minus 3y equals 6. My x value is 12, and my y value is 6. So I just plugged in those two numbers, all right? I took x and y up here and plugged it in right here. All right, so 12 times 2 is 24. 6 times 3 is 18. 24 minus 18 is 6. And 6 is equal to 6. So that one, yes, it is a solution. But in order for it to be a solution to the system, it has to work for both. All right, so now I'm going to take it and plug it into my second equation. All right, again, x is 12. Y is 2, so y is 6, so plug in 6 for y, and I get 12 equals 12. So again, that's a true statement. So since both of those are true, I can say that, yes, this is a solution. All right, I would like you to go ahead and plug in the point -1, 2 for both of these equations and tell me yes or no if it is a solution. All right, for this one, you can see I got no. Notice the equation on the left worked out perfectly fine, but the equation on the right, I got -6 is equal to 6, and that is not true. So therefore, I would say no, this is not a solution. Okay, so let's get into solving equations by graphing. All right, so remember to graph an equation, you need a slope and you need your, I guess we'll say our y-intercept, our b. So for this one, our slope is 2/1 and our b is 0. So I'm going to start at 0 and I'm going to go up 2/1, up 2/1. And you do want to use a straight edge when you're graphing because it's going to help you, make these more accurate. I know on my math lab, Does not want to work with my straight edge here. And there's my line. All right, now let's graph the second one. My slope is -1/1, and my b is 3. So remember, b is your y-intercept. So that's going to be the point 0, 3. And I make a point. I go down 1/1, down 1/1. Draw my line. All right. And our solution is going to be where they intersect. So this point right here is going to be our solution. Let's see, that's going to be 1, 2. All right, so you're graphing it just like we've done before. And then you're going to tell me where they intersect. All right, so I'm going to get you started on the next one. And I'm going to have you finish it off. All right, so when you get an equation like this, it is not in the form y = mx plus b. So I always find it easiest to put it in the form y = mx plus b. So if I look at this first equation, you'll notice my x is on the wrong side of the equation. So I'm going to add x to both sides, and I get y = x minus 4. Okay, this is now in y = mx plus b. All right, let's look at my second equation. Again, x is on the wrong side of the equation. It's supposed to be on the right side if we are in y = mx plus b. So I just subtract 2x from both sides, and I get y = -2x plus 5. All right, now that you have two equations in the form y = mx plus b, I would like you to go ahead and graph those and tell me the solution. All right, for your solution of that one, you should have gotten 3 and -1 is where those two graphs intersect. Okay, so these were both examples of graphs that had one solution because they intersected at one point. Okay, next, I want to show you some examples of those other two types of situations we can have. Okay, now these are both not in the form y = mx plus b. So I'm going to get them in that form so that it's easier to graph. So on this one, let's see, we have to subtract x from both sides. And then I need to divide everything by a -2. So this is going to be 1/2 x minus 2. All right, let's look at this other one. X minus 2y = -2. So I'm going to subtract 2x or 1x from both sides. Divide everything by -2. And I get y = 1/2 x plus 1. Okay, so here are my two equations. And I'm going to go ahead and graph those. So this first one here, my m is 1/2, and my b is -2. Up 1/2, up 1/2, and there's my line. My second equation has a slope of 1/2 and a b of 1. So again, up 1/2, up 1/2. Now, notice both of my equations had the same slope. And remember, when two lines have the same slope, that means they are parallel. So it shouldn't be shocking that these two lines did not intersect. So since there is no intersection, the answer to this one is no solution. All right. I would like you to get some practice at solving this for y equals mx plus b. So take 3x minus y equals 2 and put that into y equals mx plus b. All right, when you did that, you should have gotten y equals 3x minus 2. And now we have to do the same thing for my other equation, 12x minus 4y equals 8. So go ahead and solve that for y equals mx plus b. So for that one, you should have also gotten y equals 3x minus 2. So notice these are the exact same thing. When I graph them, my slope is 3 and my y-intercept is negative 2. So y-intercept at negative 2. Remember, this is 3 over 1, so up 3 over 1, up 3 over 1. There's my line, and you can see that if I went to graph my other one, since it's the same equation, it has the same y-intercept and the same slope, so that line is going to fall exactly on top of this one. So when you get two lines that are exactly on top of each other, our solution here is all real numbers. Okay, and another way to write that would just be negative infinity to positive infinity. Every single number is going to be a solution to that equation.